Hello, this lesson is going to be on Chapter 2, Lesson 2.5, percent of change, and we will also be talking about percent error. Okay, so the definition of percent of change is a ratio that compares the change in quantity to the original amount. Now here's the equation for it. Okay, so it says percent of change equals, and then there's a fraction or a ratio, right? In the numerator it says amount of change or the difference. And I know that when I taught you guys, what I put was new value minus the old value. Okay, remember I said that you can switch it if the larger number is the second number. So I think instead what the book uses, I like a little bit better now, amount of change, which is just the difference. So you can subtract either way, over the original amount, and I think I put the old value. No, I don't think, I know I didn't. I put the old value underneath. Okay, and then times 100. Now, in the book, it does not say times 100, okay? But I think it's easier. So, in this case, here's the equation. Percent of change equals amount of change over the original amount times 100. Now, here's some other definitions. Percent of increase. If the original quantity is increased, okay? Second one, percent of decrease. If the original quantity is decreased, and I will show you what I mean. I should have underlined this here, original, okay, once we start getting into examples. Okay, so here's the first example. It says, find the percent of change in the cost of gasoline from 1970 to 2010. Okay, so we're finding the percent of change. Round to the nearest whole percent if necessary. Okay, so they give us two quantities. They give us the price of gas in 1970 and in 2010. In 1970, it was $1.30, okay, and then in 2010, it was $2.95. So they want to know the percent of change, the change that it went from 1970 to 2010. Okay, so the first thing that we have to do is write out the equation. Okay, so again, our equation is percent of change equals amount of change, okay, the difference, over the original amount times 100. Okay, so first of all, the amount of change. We need to find the difference between the two quantities that we received, okay, and that was $2.95 and $1.30. Now, when you subtract, you always put the bigger number on top, okay, so we're going to put $2.95. Oops, okay, subtracting $1.30, okay. So now we're just going to subtract, and remember, when you subtract decimals, the decimals have to line up, okay? It's different from multiplying and dividing. Okay, so 5 minus 0, put the decimal there, it's 5, 9 minus 3, 6, and 2 minus 1 is 1. Okay, so now we have $1.65. That's the difference, that's the amount of change. So when we put it into the equation, I'll do a little squiggly here, okay? I'm going to write percent of change, I'm just going to write percent of CH, okay, equals the amount of change, which we found out to be $1.65, okay, over the original amount, Now, what year came first, 1970 or 2010? 1970, okay, so the amount for 1970 was $1.30, so that's the original amount. That was what it originally was back in the day, okay, well, not really back in the day, but you know what I mean, to you guys, it's back in the day. Okay, so then times 100. Okay, so now, basically, if you look, we are looking for the percent of change, correct? So when we're looking for something we don't know what a number is, we use a variable, okay? So we can use x, we can just replace it with x. So x equals 1.65 over 1.30 times 100. Okay, now there's two ways we can do this, okay? And I taught you guys both ways. So I'm going to show you guys that on the next page. Okay, so I split the page up into two so that I can show you both ways to do this. Okay, now the first way is when you look at this, okay, again, it says x equals 1.65 over 1.30 times 100. First thing, okay, you could first do the division, okay, then when you get your answer, multiply by 100, okay. Now just to save time, when you divide 1.65 divided by 1.30, you get a long answer like this. 1.269230077 ... Okay, now remember, times 100. You can't forget that. Times 100. Okay, now the easy thing is when you multiply by 100, tens, 100, 1,000, okay, you look at the zeros, and there's 2 zeros in 100. So we're going to take this decimal point, and we're going to move it 2 spaces to the right. 1, 2. Okay, so now we have 126.923077. Dot, dot, dot. Okay, so now we are looking for the percent of change, okay? And then in the directions it said round to the nearest whole percent if necessary. So the whole percent here is the number before the decimal, right? Which is 126, okay? So we look at the 126, or specifically at the 6th, the last digit. Look at the number to the right. It's the 9, okay? Remember, 5 or higher, up the score. 4 or less, let it rest. 9 is higher than 5, so we're going to up the score. We're going to up 6 to a 7, okay? So your answer is going to be 127%, okay? Now, the other way, on the bottom, I wrote the same thing. X equals 1.65 divided by 1.30 times 100. What you could do differently here is you could multiply by 100 first. You can make 100 into a fraction. And when you make a whole number into a fraction, you have to put it over 1. Okay, so now it says 1.65 times 100 over 1.30 times 1. Okay, now again, 1.65 times 100, okay, you take that decimal point and you move it 2 spaces to the right. 1, 2. Okay, so now you really have 165 over 1.30 times 1, which is just 1.30, okay? Then you divide, and when you divide, you get this. Get 126.923077 dot dot dot. Ooh, looks like the same exact thing on the top, right? Now again, round to the nearest percent. So you have to do the same exact thing. You look at the percent, you look at the whole number, right? Specifically the 6. Look at the next number, it's a 9, raise the score. So again, our answer is 127%. So you can do it either way, whatever way you feel is easier for you. Okay, and you'll get the same exact answer. So the cost of gasoline increased, right, by about 127% from 1970 to 2010. Okay, next example. It says, okay, a DVD player. It was bought for $280. Okay, so you went to the store and you bought the DVD player for $280. Okay, now all of a sudden you see the next day it's on sale for $220. Okay, well that's sad. Find the percent of change. Round to the nearest whole percent if necessary. Okay, so we're gonna do the same exact thing. We're gonna use that formula, which we're gonna put on the next page. Okay, so percent of change equals amount of change over the original amount times 100. So first thing that we need to do is we need to subtract, right? We have to find the difference between the two. So when you bought it, it was $280, and now it's $220. Okay, so we're going to subtract the two. The bigger number is 280, so we're going to put that number on the top. So we got 280 minus 220. Okay, 0 minus 0 is 0. 8 minus 2 is 6, and 2 minus 2 is 0. Okay, so we really have 60, right? So the price, right, was a change of $60. Okay, now think about it. Was it an increase or a decrease? Did the price go up after you bought it, or did it go down? It went down, right? So it's a percent of a decrease in this case, okay? So when we have this now, percent of change, which is going to be our x equals the amount of change, which we just found out was 60, right? $60, so 60. Now the original amount, what did you originally pay for it? You originally paid $280. So that's what's going to go in the denominator, okay? Times 100. Now again, you can do this any of those two ways, okay? And again, I will show you both ways. Okay, so first way, right, was to do the division first, then multiply by 100, okay? So we're going to be dividing 60 divided by 280. Now, one thing I just want to throw out there is, do you see how there's two zeros? I'm sorry, there's 1 0 here at the end of the number, and there's a 0 here at the end of the number. When you see that, okay, what that means is that both of those numbers are divisible by 10. Okay, so if you divide those numbers by 10, basically what happens is, this is really a decimal, right at the end of both numbers. Let me make that a different color so you can see that. Okay, when you divide by 10, okay, at any number, the decimal point moves one space to the left, okay, because 10 has 1 0, so it moves one space to the left. So when we do that, right, you would have x equals 6, right, over, so it would be 6.0, but you can just get rid of that 0, over 28.0, right, times 100. So if you look, what you could do, why isn't this working? What you can do is if you see that both numbers that you're dividing have a 0 at the end, you can just cross them out. They disappear. Look, x equals 6 over 28 times 100. Okay, that's basically the same thing that I have here. That's just in decimal form. Okay, so that's a little bit easier now. If you did it where you did 60 divided by 280 times 100, you would get the same exact answer, just like if we're going to do 6 over 28 times 100. Okay, so when you divide 6 divided by 28, you get 0.214 dot dot dot. Okay, then remember times 100. Okay, again, remember, when you multiply by 100, you move the decimal point 2 spaces because of the 2 zeros, and you're multiplying so it's to the right. Okay, because when you multiply, you make something bigger. You make the number bigger. Okay, so let's do that. 1, 2. Okay, so now you have 21.4. Okay, now remember in the directions it said round to the nearest whole percent. So again, we're going to look at the whole number here, which in this case is 21. Okay, specifically the 1. Look at the number next to it. 5 or higher, up the score. 4 or less, let it rest. It's 4 or less, so we're going to let it rest. Okay, we're going to let the 1 rest. So the answer is going to be 21%. Now I just ran out of some room, so I'm just going to delete this. Oops. Delete this here for a second. Okay, so it's going to be x equals 21% decrease, right? Because the price went down. Okay, so now let's do the next one. Now in this case, we're going to do the multiplying, right? So we're going to put 100 over 1. Now again, we can remove those zeros. It just makes things a lot easier. So let's just do that. Goodbye. Equals 6 over 28 times 100 over 1. Okay, so 6 times 100 is 600. Right? 6 times 1 is 6, add the 2 zeros, and then 28 times 1 is 28. So now you have 600 divided by, 28. 600 divided by 28 equals 21.42, dot, dot, dot. Same thing. Look at the whole number. 21, specifically the 1. Look at the 4. 5 or higher, up the score. 4 or less, let it rest. It's the same thing that we did on top. Okay, so it's let it rest. We're going to let the 1 rest. So your answer is going to be 21%. That's the same exact thing that you got before. Okay, so this is a percent of decrease, remember, because the price went down. Okay, it went from 280 to 220. So the price of the DVD recorder decreased by about 21%. Okay, now the other thing that we did was percent error. Okay, it says a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. Okay, so in class, what we did was I gave you guys that worksheet of celebrities, and you guys had to guess the ages of the celebrities. Then I gave you the real ages of the celebrities, and you guys had to find your percent error. Okay, so I'm going to guess about somebody's age, and I'm going to. Okay, what about like Justin Timberlake? All right, I don't know. He must be in his 30s. I'm thinking 31 years old. Okay, so that's my guess. That's my estimate. So I think JT is 31 years old. Okay, I'm going to look online and see how old he really is. Oh, so close. He's 33. Okay, so his real age is 33 years old. Okay, so that's the what right? Real age. Okay, so there is an equation that we're going to use, and it's very, very, very similar to percent error. I'm sorry, my goodness, to percent of change. Okay, it's very similar. So that equation is as follows. So percent of error equals amount of error. Okay, so again, the difference, right? The difference between the two, whatever the quantities are, in this case, it's the age, okay, over the actual amount. Now, the amount in this case is Justin Timberlake's age times 100. So the first thing that I have to do to find the amount of error is subtract, okay? So I guess 31, he's really 33, okay? So the bigger number is 33, so we're going to subtract 33 minus 31, all right, which 3 minus 1 is 2, and 3 minus 3 is 0. We don't really need that. Okay, so it's 2 years. I guess 2 years off. Okay, so we're going to put that into the equation now. So the percent error is our x, right? So it's going to be x equals the amount of error, which is 2, over the actual amount, his actual age, his real age. His real age was 33. Okay, times 100. We can do the same thing from before. We can either divide, then multiply by 100, or multiply by 100, then divide. Okay? So, personally, I like to multiply by 100 first. Okay? So we're just going to do that. And if you like the other way, that's totally fine. I'm just trying to save time. Alright, so x equals, I'm going to write 2 over 33 times 100 over 1. Okay? 200 divided, oh my goodness. I always do that. 2 times 100 is 200. Okay, and then 33 times 1 is 33. So now I just have to divide 200 by 33. Okay, when I do that, I get x equals 6.0606. Okay, so basically it's 0.6 repeated. Okay, now in this case, I want to round to the nearest whole percent. Okay, so when I do that, I look at the whole number, which is the 6. I look at the number to the right, which is a 0, 5 or higher, up the score, 4 or less, let it rest. I'm going to let it rest. So my percent error was about 6%. So remember, it's basically the same exact thing as percent of change. It's very, very similar.